Okay, welcome back, everyone. And this will be a quick one about water balance in the body. So, on a typical day, you might take in about 2,500 milliliters, which is like 3 quarts of fluids. Sometimes a little more, maybe some days a little bit less. But most of that intake will come through the digestive tract, but you might not realize that about 230 milliliters, which is 8 ounces a day, is generated metabolically. And by the way, that's happening in the last steps of aerobic respiration, where those protons are joining up with oxygen, and that makes H2O water. Additionally, each day, about the same volume of water is going to leave your body through different routes, mostly through urine, but through sweat, exhalation, and other things like that. So, um, the kidneys could also, like we just learned, adjust blood volume through mechanisms that draw water out of the filtrated urine. And the kidneys can regulate water levels in the body. They can conserve water if you're dehydrated, and they can make urine more dilute to expel excess water if that's necessary. Water is lost through the skin through evaporation from the skin surface without even knowing you're sweating, and from air expelled from the lungs. That type of water loss is called insensible water loss because you're really not sensing it, you're unaware of it. Every time you breathe out, you're expelling water, and water is evaporating from the surface of your skin, even if you don't think that you're sweating. Um, if we're going to regulate water intake, there's three ways. There's a few ways that in which we do that. So, osmolarity, first of all, is the ratio of solutes in a solution to a volume of solvent in a solution. And by that note, plasma osmolarity is the ratio of solutes to water in blood plasma. A person's plasma osmolarity value reflects his or her state of hydration. A healthy body will maintain plasma osmolarity within a narrow range by employing several mechanisms that regulate both water intake and output. So, let's talk about how the body does that. So, first of all, drinking water is actually considered to be voluntary, right? Because you have to choose to do it. So, normally when we talk about how the body regulates things, we're not talking about voluntary actions. So, if somebody's dehydrated and the only way that you can do something yourself is to drink something, what are we talking about exactly when we talk about regulation? Let's just consider this graph. So we have somebody who's dehydrated. And by the way, if you're not sure, dehydration is a net loss of water that results in insufficient water in blood and other tissues. And the water that leaves the body as exhaled air, sweat, or urine is going to be ultimately extracted from blood plasma. Okay? And so as the blood becomes more concentrated, eventually the thirst response, which is a sequence of physiological processes, gets triggered. Osmoreceptors are sensory receptors in the thirst center in your hypothalamus, and they monitor the concentration of solutes, or basically the osmolarity of the blood. If the blood osmolarity increases above its ideal value, the hypothalamus transmits signals that result in a conscious awareness of thirst. You're going to start to feel thirsty. Then at that point, you should, and people normally do, respond by drinking water. Um, the hypothalamus of a dehydrated person also releases antidiuretic hormone through the posterior pituitary gland. And we've talked about antidiuretic hormone before, but it signals the kidneys to recover water from urine. So eventually you're going to be producing less urine, and it's going to be more concentrated urine. And that'll effectively help to dilute your blood plasma. Now, if you remember, alcohol acts as a diuretic by inhibiting the release of antidiuretic hormone. And what happens is you're going to urinate a lot more than you normally would, and you're going to end up being very dehydrated because of that. And that, of course, leads to hangovers. By the way, caffeine is also a diuretic, and that should make you pee more. So if you've ever had coffee, you know that you usually tend to have to urinate a lot very quickly after having coffee. So in order to conserve water, the hypothalamus of a dehydrated person will also send signals via your sympathetic nervous system to your salivary glands in the mouth, and that will signal result in a decrease in watery saliva, and it'll increase a stickier, thicker mucus. And what is that? That's basically cotton mouth or dry mouth, and that also increases the sensation of thirst, or just I need to get a drink, right? When you have cotton mouth. When you have decreased blood volume resulting from water loss, that'll also result in two other things. The first are we have things called baroreceptors, which are blood pressure receptors in the arch of the aorta and the carotid arteries in the neck. And those will detect a decrease in blood pressure, and that which results from a decreased blood volume because there's not as much water in the plasma. And that the heart will ultimately be signaled to increase its rate and or the strength of its contractions to compensate for lower blood pressure. And second, the kidneys have that RAS system, the renin-angiotensin hormonal system, and it increases the production of the active form of that hormone angiotensin 2, and all that does is it helps stimulate thirst and stimulates the release of the hormone aldosterone from the adrenal glands. Aldosterone increases the reabsorption of sodium in the distal tubules of the nephrons and your kidneys, we just learned about, and water follows this reabsorbed sodium back into the blood. If, let's say, all these things happen, but we don't consume adequate fluids, dehydration results, and a person's body will contain too little water to function correctly. Dehydration is obviously a very bad thing. A person who might be repeatedly vomiting or have diarrhea, that you lose a lot of water that way. And infants, because their body mass is so low, can become dehydrated very, very quickly. Endurance athletes, like long-distance runners, they'll become dehydrated during long races. And dehydration can be a medical emergency. A person might lose consciousness, become comatose, or even die if your body is not rehydrated quickly. So it's nothing definitely to be to laugh off. It's something that's really important. So everyone make sure that you're drinking your water. The last slide here, how does the body regulate how much water that we're outputting? Water loss, like we just learned, it predominantly occurs through our renal system, right? The urinary system. On average, you're going to produce about 1.5 liters of urine a day. And although the volume of urine will vary in response to how much hydration you have, there's actually a minimum volume of urine that has to be produced in order for your body to function, because you've got to get rid of these solutes in your body because they can become toxic chemical wastes like creatinine, urea, uric acid. All of those things have to get excreted. So if you don't create this urine and excrete it, your body's going to be in some trouble. If you fail to do that, that means that those metabolic wastes are going to be stuck in your body, won't be effectively removed, and that can actually really impair organ function. If you're interested, the minimum level of urine production necessary to maintain normal function is about 0.47 liters, half a quart a day. We also just went over this, but the kidneys can also make adjustments in the event of ingesting too much fluid, and that's called diuresis, and that's the production of urine in excess of normal levels. That'll begin about 30 minutes after you drink a large amount of fluid. You're going to have to pee a lot right after. That reaches its peak in about an hour, and then you're back to the normal production of urine after about 3 hours. And so that's all I'm going to do on this video. We'll be back for a few more in this chapter.